Have you ever wondered how banks are keeping your money safe? And how banks monitor their credit risk? Before our presentation, we will show you a short animation outlining the business problem, the solution, and how technology can help. Meet Charles.
Meet Charles, a credit risk manager at a bank. On a daily basis, Charles is responsible for monitoring the risks related to lending the bank's money to other companies. The problem nowadays isn't getting information, but getting the right information. The big data world is Charles's struggle. It's impossible to read all the news about these companies, and often it comes in a language that Charles doesn't speak. And even if most is just noise, sometimes there are really relevant and even urgent things mentioned in local news. Wouldn't it be great to help Charles do his job even better and stay on top of the credit risks the bank is facing? For that, we created Early Warning System, a machine learning-based application that is trained to process all the data that becomes available. With Early Warning System, Charles gets proactive signals about his counterparties that he needs to look at on the devices he has. These signals come from all the local markets, where his clients are active in all different languages. Early Warning System translates everything into English so that Charles understands. This saves him lots of time and makes his life in the big data world much better. Early Warning System.
Good afternoon. My name is Otto Vermeulen and I am a technology partner at PwC. I'm very pleased to be here at Cloud Next 18. What we have seen is that the main business challenge for Charles is getting the right information at the right time, and that his problem could be solved if he gets information from around the globe at the right time. So that's why we built an early warning system for credit risk management. Extracting insights from public data from around the globe, which enables the credit risk managers to focus on important events and also supports their decision making. And how and why is that possible now? It is possible because we have nearly unlimited compute power and storage capacity from the cloud. We have a whole range of APIs and algorithms for machine learning, and also because we now work agile, enabling fast experimentation. So that enabled us to build a proof of concept in 12 weeks' time. I will now walk you briefly through the agenda. First, I introduce the team and explain how we did come together. After that, ING will explain why this use case for credit risk management is so important to them. Then we will elaborate on our approach of this proof of concept and the design of it. And after that, we will explain the technical solution, including a technical demo. Then we'll wrap up with the key takeaways of this project. As you can see, we are here with three main parties. They are ING, Google, and PwC. And how did we come together? Well, easy. Google approached us and indicated that ING had the idea to collect real-time news and perform corresponding analysis for the credit risk management department. And they asked whether we would be willing to work with them, which of course we would. So we quickly built a demo, and the demo convinced ING that they were on the right track and needed to explore this further. So they asked us to build this proof of concept. Before I now hand over to the next speaker, I will introduce the team. First of all, we have Anand Autar. Anand is the executive owner of this project and the head of portfolio management at ING. He is also the father of this project. In Anand's team were the executive sponsors, 5 core team members, and over 30 test users. Then from PwC, we have, apart from myself, Peter Verheijen. Peter is the engagement leader of this project and leads our banking innovation practice in consulting. Peter will be followed by Peter Wiggers. He's a cloud-native architect and our technical lead. And his hobby is Kubernetes, and we'll hear a lot more about that later. Also in our team were data scientists, a UX designer, and a front-end developer. And then, not on the presentation, but equally important, Petra Stojanovic from Google. She is the account manager for ING and has given us tremendous insights and access to the right experts within Google. So now, we've seen the animation, we've had an introduction to the project and the team, and it's time to hand over to Anand Autar. Anand, over to you.
Thanks. Thank you all. As Otto mentioned, you could see me as the father of this project, and I'm quite proud of it, where we are now. I started with early warning systems about a few years ago now, and we as ING are quite excited to be able to share with you what you can do with today's technology. We developed this tool within the wholesale credit risk management space, which means that we focus on clients such as large corporates, financial institutions like banks, insurance companies, and countries. What personally makes this project really interesting for me is the fact that it actually shows that also in the risk management space, we're innovating as well. And in line with ING's strategy, we're trying to stay a step ahead. As you could see in the introduction movie, we have to deal with a lot of information these days. And what I will try to do is actually explain why we started this with all this information overload that we have today. To do so, I will first start to explain to you what credit risk management is, and then I will actually guide you through an example using the workday of a credit risk manager. So let's start with, what is credit risk management? To answer that question, I'll actually go back to the basics of banking. If you look at banks, banks are a place where you go to deposit your money, to borrow money, or to transfer money from one place to the other end. In essence, we're just a financial services company. So if you, as an individual, deposit your money with a bank, the bank will actually lend that money to a client who is in need of money. And when we do that, we actually run a risk. And that risk is called credit risk. It's the risk that when we lend out money to a client, we run the risk that the client will not be able to repay that money. In other words, they won't be able to adhere to the obligation towards the bank. If you look very closely to this picture, you will actually see that you as a private individual are also running a risk, but then on the bank. And as a result of that, we are a regulated entity. So we need to abide to a lot of rules and regulations just to make sure that your money is safe with us. And within this whole scheme, having proper early warning systems are quite important. So now let's look at what happens when we actually lend out money. What we'll do to assess the risks, we'll do a lot of analysis. We'll look at the financial health of a company. We'll look at the management team of the company, whether they're able to actually adhere to the strategy that they've set out. We'll look at macroeconomic type of events. We'll look at the balance sheet, the net profitability of the company, and so forth. And what we'll do is actually, we input all these variables into what we call a credit risk model. These are models that we've internally developed, which have also been validated by independent parties within the bank, and often by the regulator. So when we input all these variables, we get a risk rating. And a risk rating is nothing more than an output of a model, and it gives you the classification of the risk. So within ING, we use a number code. 1 being very good risk, whilst 18 being very bad risk. External rating agencies actually do the same thing. They use AAA for very low risk, whilst BBB and beyond is very high risk. So when we've engaged with a client, and we've determined actually that we're willing to run the risk because it's within our risk appetite, what we'll do is we'll start monitoring that client, which means that we're actually starting to see whether there are any signals out there which actually causes any potential issues that we would have with the client going forward. This is what we call early warning signals. And then on a daily basis, what we'll do is we'll use sources like news, market prices, but also like interim figures. I can give you a lot of examples of early warning signals, but these are quite different per type of client and per type of industry. So what I'll do, is I'll just run you through the day of a risk manager. So let's meet Charles. Actually, he's almost the same guy as in the introduction movie, but then with a different hair color. Well, Charles is a credit risk manager who has a portfolio of 100 clients, which are globally active. He has been with the bank for about like 10 years. He's a very seasoned banker. So he actually has developed the sixth sense, which actually tells him when he's looking at a transaction whether it's a good or bad risk. And in line with all credit risk managers who are out there, we don't like any type of surprises. So let's look at Charles' day. First of all, he gets into the office, he grabs a cup of coffee and then goes through his pace. Basically, he looks at the risks, the news, which is relevant for his portfolio. And then he also runs through all the transactions. So he looks at transactions that he needs to approve or whether he will decline them. He looks at annual reviews. And he also looks at rating models. So Charles has quite a busy day. And in that day, he also needs to make sure that he captures all these signals and information out there for his 100 clients. Now let's imagine the following. One day, Charles is actually reading the newspaper, a global newspaper, and he finds out that one of his clients is involved in a bribery case in a very specific country, which surprises him because he didn't know about them. So, being a risk manager, he starts digging in deeper. And then he finds out that actually this information was already available a month ago, but only in that very specific country and in a very specific language. Digging deeper, he actually finds out that the stock price has been declining for like a month for 10%, and they didn't know about that. As you can imagine, Charles, being a person who isn't fond of surprises, he's quite upset. Now let's look at another example. Meet Lauren. Lauren is also a credit risk manager, but then for banks and for countries. And her portfolio is actually much more geared toward market-based type of prices. Okay, thanks. I hope you can hear me now. Okay. Well, actually, what it means is that Lauren has to look whether the risk rating profile of that client needs to be adjusted or not. But one day she finds out that the news was already available a day ago when the external rating agencies downgraded the country. Like Charles, she's not really happy. So what do Lauren and Charles have in common? Well, basically, they have to deal with a lot of information whilst they have to do their regular day job. Imagine that you have like 2,000 counterparties across the globe in 75 languages with more than 20,000 sources that you get information from. That's a lot. So they run the risk of losing out on early warning signals. So we identified this problem within the wholesale risk management space, and we wanted to have a tool which actually gives us information which a big coverage in news, market data, which is relevant for the risk manager. So we can actually move faster and catching these signals, and much be more proactive as a risk management department and moving toward what we call a continuous monitoring framework. So the tool that has been built now is actually a first step. It has global and local news sentiment. It has market prices, such as equity, CDS, commodity prices. And for countries, organizations, and sectors. Users can actually set their own threshold levels, and when something is breached, the tool will actually signal or give a notification to the user. For us, this is a first step, because we always anticipated when we started with this project that we want to have a tool which is much more predictive. Remember the sixth sense that I talked about with Charles? Well, Charles, this sixth sense is nothing more than a heuristic that he developed across the years. And we believe that with the current data which is available, but also with the existing and future machine learning technology which is out there, we can make a tool that is much more predictive. So why did we build it from scratch? Well, we as ING, we're a data company. And we think that it has a lot of advantages to build these type of applications yourself. First of all, in today's world, it's relatively easy and you can build these tools quite quickly for a very specific use case. Second of all, it gives you a lot of flexibility. It makes you also independent from other solution providers, which actually provide a lot of features that you often don't need. Besides the fact that we as ING want to be masters of our own destiny, we've actually proven that we can build these type of tools ourselves. So that's why we actually partnered up with Google and PwC to build this tool. We're at the stage now that we have tested the tool across 8 countries with 30 users, and we're now determining the next steps in developing the tool further, but more importantly, to embed it in our core monitoring processes going forward. So I hope now you get a better feeling why we need to have the tool, but also that credit risk management is a very data-driven and also a very analytical function within the bank. Well, with that, I want to thank you for your attention. Sorry about that. Thank you for your attention, and hand it back to Otto.
Thank you, Anand. That was very clear. I think we now know what the bank does and that credit risk management is extremely important to them. Also good to hear that the proof of concept addressed your early warning signal challenges and also that you are looking forward to use machine learning to get more predictive signals. So now I think it's time that we hear about the project has evolved and what the design principles were. So over to Peter Verheijen.
Hey everyone. It's great to be here and talk to you about our proof of concept. Personally, I'm very passionate about solving important problems and making innovation really happen. And I will, in my part, run you through the approach that we applied to this proof of concept. Secondly, the design of the solution and the underlying business needs. And thirdly, I will give you a demo of the solution itself. To start with the first part, the approach. For me, there are 3 crucial ingredients that have been part of this proof of concept. The first is the team. You need to have the right skills and people to deliver fast. In our case, we created 5 skill sets. An IT architect, a user experience designer, a user interface developer to implement the design, data scientists to build models to detect early warning signals, and credit risk expertise from Anand and his team to tell us actually what is relevant to see. My lesson learned from building such a team is that you need to find the right balance. The balance of experts who can deliver very fast in their area of expertise, but also skill overlaps so that you build in the end a solution that fits together. The second ingredient was the way of working. We really were benefiting from direct user feedback all the time. We applied an agile way of working, and we started with a demo that was only built in 2 weeks' time, shown to the end users. And based on that approach, we got very valuable feedback and a dialogue that we could build upon for the rest of the project. We took that feedback into our backlog, started planning the first sprint, and from that moment on, the rhythm was there that we could work with the end users continuously. The third ingredient was scoping. We only were using public data in the beginning, and that increased the speed tremendously. We didn't need to connect with any other existing IT system within the bank at that point in time, and that was very important for us. Now, the approach that we applied had 3 phases on a high level. The first phase was really the beginning, when we needed to start from scratch. Nothing there on the Google Cloud Platform environment, just a project name. Then we started with the 3 ingredients that I just explained, and with the services available on the Google Cloud Platform to develop the solution in sprints. And I think the success factor was that we had a successful demo every sprint, and at the end of 6 sprints, a working proof of concept ready for user testing at that time. In our case, this for me really demonstrated the power that you get from building proof of concepts with the Google Cloud. That you can really go fast with your proof of concepts. In our case, it was a successful proof of concept, so we decided to move on. And the second phase was about testing it with users. As Anand explained, 8 locations, around 30 users. And through those user pilots, we gathered a lot of feedback and data that we could use to retrain the models from a machine learning perspective and decide what is actually relevant to see for users. And now we are in the third phase, where we are deciding how to roll this out further and take this into production, into the core processes of the bank. Now, that was the approach on how we did this proof of concept. Now, quickly, I would like to take you through what we exactly built. This is a very simplistic representation of our solution. On the bottom, you see 2 types of data sources that we ingest. Firstly, market data in terms of equity prices, credit default swaps, bonds, and other financial instruments coming from Thomson Reuters based on the license that ING has with them. Secondly, news coming from public sources via Google, GDELT, and others. That's something we uploaded into the Google Cloud Platform, ingested, and there we have built a pipeline to process and analyze that information. In that middle layer is also where the machine learning is happening. And then, based on that pipeline, we decide what to display to a user who's able to log into an interface and from there get that information to him. On the right side, you see some statistics of what we are actually processing. The current scope is around 250 clients or organizations in the tool, and you can get an impression of the amount of information that we are processing on a daily basis. Now, that was a very simplistic picture. And actually, through those sprints, we encountered some very specific business needs that we needed to fulfill and overcome to build a successful proof of concept. 5 are here on the screen. You need to have maximum coverage, deliver the signals in real time with enriched information so that you're sure that the imputation is right, filtered and ranked based on relevance, and then in the end clustered into single events. And I will go through each of those in more detail in the coming slides. The first part is coverage. We really learned that entity profiles drive the coverage that we were looking for. In one of the first demos, we actually got the feedback that we were missing out on important information. And as Anand explained, you don't want to miss out on those signals. The reason for missing out on information was that we were only looking for information with the parent company name. And actually we learned that we should take a different approach. We should build entity profiles with all the aliases, subsidiaries underneath that company in different languages, as you can see here as an example for ING. And in that way, we have been able to increase the coverage with a factor 5 to 10 on average for each client. Now, the information is then coming in, and you want to process that in real time. That's a key requirement for a risk manager so that he gets those signals fast and can respond to them. As you see here, for an average risk manager with a portfolio of 50 clients, that's quite a lot of information that we need to handle. On a daily basis, you talk about 15,000 news items, 250 financial instruments, which are continuously moving. And that's all something we need to be able to process in real time. So how can we help the risk manager to stay on top of these things? In the technical part, done by Peter, we will talk about the architecture and the way we developed the solution to meet this requirement. The third one is enrichment. So, as a risk manager, you actually want to have information that is truly about the organization that you are responsible for. So you need to be able to cut out the false positives. As the example here shows you, if you get an average news item, you see a lot of actors mentioned in the news item. So if you do a keyword search, for any of the organizations, this item would pop up. But if you are looking for early warning signals, only in the case of oil company E, this is a true positive early warning signal. So the rest are just false positive, and you want to filter those out. So you need to go beyond the keyword method and applying techniques to understand who, what, when, and where this event actually is happening. And we use the natural language processing technique for that, and we will show later on how that works. The fourth part is, now we went very broad, a lot of information is coming in, we also enriched that, so it's really about this counterparty or client, but now there's still too much information to handle, so you need to be able to filter that information and select the items which are actually relevant for a credit risk manager to take a look at. As you can see here, there are also some examples of things you don't want to take a look at as a risk manager. So if you are responsible for monitoring a bank, and you get in the global news, you also see a lot of local news about ATM incidents, for instance, negative sentiment, but not relevant for a credit risk manager on that level. Same with car manufacturers. You get in news about car accidents as well. So what we need to do is actually make that distinction in our pipeline to detect what type of topics are relevant for a credit risk manager to take a look at and cut out the other part, which is just noise for him. And then the fifth one is the clustering. So now we have relevant items to take a look at, but as you can imagine, if such an event happens, more publishers are writing about it, and it becomes a very annoying experience for a user that you get that same news message over and over again, but then from a different news publisher. So what you need to do to solve this is build a clustering algorithm that understands that actually based on the text, this is talking about the same event, and that's what we did, so that you cluster it into a single event and bring that message only once to the user. Now, these are the 5 building blocks of our solution. The last thing I would like to do is take you through a demo of what the solution now really looks like. For the purpose of the demo, we don't want to harm anyone here in the room with showing real early warning signals, so we created a simulated data set with dummy names and dummy news items. The rest of the tool is working just as it is. Now, Charles is logging in. As you can see, nothing there yet on his homepage. So the first thing he does is he goes to his portfolio and he wants to add counterparties to his organization. A list, but you can also start searching for names. So that's what he's doing right now. And he adds a second organization to his portfolio. Third one. And the fourth organization. So now he has 4 organizations in his portfolio. Yes, there they are. And then he will click top left, going back to the home page. And on the left side of the screen, you see the newsfeed. And the newsfeed has factors like sentiment score, dates, entities found. You can also filter on the time period. You can filter the news on various factors like relevance or sentiment negative, or popularity, which means, how much is written about it. And then here you see that he goes to a specific article which has 5 similar items. That's the clustering. So these are all about the same event in different languages with different titles. So this is, I think, Chinese. A French article, FR, is French, translated and then clustered into that single event. On the right side, you see the market information, so equity prices. So the first one is a negative one, so it went down. So he takes a look at this specific counterparty page with much more detailed information. Equity price, credit default swap, credit ratings. But actually, this is all very reactive. You need to go and look for the information. But what you can do as well is there set your triggers and make it proactive. So let's say the equity price drops 5% in a day. That's what he's doing now. He adds that to his portfolio. You can do the same thing with, for instance, keywords, In case of fraud, for instance, if there's a news item with fraud in it, I want to be notified immediately, and that's what the trigger is doing. So it's already running now in the background and checking if there are any of those triggers been hit. News sentiment, very negative, not a trigger. Credit ratings, if there's probably a downgrade, that's something you want to be notified of immediately. And in this way, it becomes a very proactive way of getting that information, because now those triggers will search for you and make sure that that information is coming to you. There's already one been hit now around fraud. So there has been an article about fraud on this specific client. Take a look, yes, there it is. And now, sentiment score of -70, so it's relatively high. And now the user is giving you feedback on this specific item. I'd like to see more about that. Or, for instance, the second one he doesn't consider relevant. So that's information we can use to actually make those models that we have running in the background more advanced with machine learning. So that was a very short demo. But I hope it demonstrated to you that we have been able to actually create a digital assistant for a credit risk manager to make his job much more easy with increased coverage, increased response time, and in the end, a proactive tool that makes sure that the information comes to him at the right time. With that, I would like to thank you and hand back to Otto.
So thank you, Peter, for explaining the way how we approach the project. You did that very well. And also thank you for outlining the business concepts which we needed. I think it's now more than time that we dive into some of the technical details of this project to show some technical meat to the bone. And I'd like to have on stage Peter Wiggers.
So my name is Peter Wiggers. I'm the cloud architect and one of the software developers of this tool. And I would like to make this presentation a bit more technical. So I'm really excited to do that. I hope you are too. So let's start with a schematic overview. Okay, it's already switching. Can you switch back, please, to the slide? Yeah, thank you. So what you see here is a schematic overview of the solution we built in the Google Cloud. As you can see, we use a lot of managed Google Cloud services, which really allowed us to develop quickly. On the left side, you see the input we use for the pipeline you see on the right side. So the input consists of the entity profiler and consists of public data sources, the news. So on the right side, we have the pipeline we built. And as you can see, it consists mainly of two very important components. One of them is Google Cloud PubSub, and one of them is Google Kubernetes Engine. This combination made sure that this pipeline is really robust, but still very flexible. And I will show you why later in the demo. This pipeline, it's separated into a couple of steps, and every step is its own Kubernetes deployment. So we can easily scale it independently from the other Kubernetes deployments, and all deployments communicate via PubSub. So the input comes from PubSub, and the output goes to PubSub until processing an article is finished. So what I want to do now is switch to the demo, please. I want to take you on a trip of an article through the pipeline. And we'll do this in a Jupyter notebook. I hope you can read it from the back. And what we will do is we will start with building an entity profile. In this case, we will just use PwC. It's the only keyword we use as an input. And we will only build a part of the entity profile, which is gathering the aliases and Wikipedia pages of this entity. So we will run this. And as you can see, we find quite some aliases, some subsidiaries in different languages, different character sets, different namings. And we use all these aliases to search for news about this company. What you also see is a couple of Wikipedia identifiers. And these are really important for us in a later stage. So what we'll do now is we'll use one of the aliases, in this case number 5, which is just PwC. And what we do is we generate RSS feed URLs to the Google News. So as you can see, we use the word as a query for this RSS feed. And what you also see is we query for specific editions. And an edition on Google News is a combination of a language and a country. So in this case, it would be a French article written in Belgium. For this example, we will query one Google News RSS feed, and we'll only use one edition, the Dutch edition. So what we will do is we parse the feed, we get the feed in, and what you see here is the first 5 articles of this RSS feed. It's in Dutch, so probably you won't be able to understand it, but that will come later. What we get from the RSS feed here is the headline, is the publish date, and the URL to the original article. So this is the first part where PubSub comes in, because before this, we have to start with a pipeline at a moment where we start with the queuer. And then what the queuer does, it was located on the previous slide. What a queuer does is it periodically publishes a task to PubSub where it says, hey, can you query on PwC, on the Dutch edition, on Google News? So that's done now. And what we now do is for every article we get from this RSS feed, we publish a task to PubSub saying, hey, can you process this article for me? And we have different workers which listen to this PubSub topic, get the task, and process it. So it's as easy as this, just a publish to a specific topic and a subscribe to a specific subscription within that topic. What I want to show you now is some statistics. So we'll open this one. What you see here is some metrics from PubSub. In the first chart, you see how many messages we publish to PubSub. In this case, well, it's about almost, I think, 2,000 per second at one point. And we do it for, I think, a couple of minutes, which leads to a total queue in PubSub of articles to process of 200,000 articles. Can be duplicates. So here you see the entire queue. And what you here see is the amount of articles the workers process. So it's about, I think, 30,000 per. This is 5 minutes. So in like 30 minutes, we process the entire queue. And then we just wait for, we search again on those entities. And this is a graph showing the age of the oldest task in this PubSub queue. So which is about 2,600 seconds. I don't know, I think it's 40 minutes. And what makes this setup really nice is that we can scale the workers independently. So let's say you think this is too long. I don't want to wait 40 minutes. If something happens, I want to know it quicker. Then we can say, okay, let's scale the workers independently, and let's scale them to, for example, the double amount of workers. And then this number, this 30,000, will increase to 60,000, and your queue will be processed in half the time. So I would like to show how easy this is. First, I'd like to know how many of you have hands-on experience with Kubernetes? Okay, that's nice. That's quite some. You probably know how to scale a Kubernetes deployment. For the people who don't, I would like to show you how easy it is. So let me zoom in a little. What we do here is we see these are the workers that process the first part of an article. You see, I think it's 12 containers or 12 pods. So what we want to do is we want to scale this. So we are not happy with this 30 minutes processing time. So what we will do is, let me type correctly there. So here it says we want to run 12 replicas. So what if we, let's say we change it to 18? So we want 50% more pods running. Then you immediately see that now Kubernetes spawns up more containers, and they are running already now, and they listen to the same pub/sub topic. So pub/sub makes sure the tasks are distributed over these containers. So if we now would wait for, I think, a couple of minutes, and the pipeline would start again, this bar would be at like 45,000 per 5 minutes. So it's that easy to scale this. So let's assume that this article arrived at the processor. Then we instantiate a new article, and we have the same information that was in the RSS feed. So the information was sent to pub/sub, and we get this information from pub/sub. So nothing added here. Just the URL, we have the original headline in the original language, and the publish date. What we do now is we give the worker the task to visit the website and collect the body from the website. So what you here see is the body of the article. It's in Dutch. And we need this for further processing. What we do after this is, of course, we translate the article, because we process, I think, 75 languages, and we all need it in English. So we use the Google Cloud Translate API to translate the headline and the body of the article. So now you know what this article is about. It says Ad van Geels is the new CEO of PwC Netherlands, and we have the translated body here. Now we have the article in English. We can use it for the Google Cloud Natural Language Processing API. And this API does 3 things for us. First of all, we want to analyze the sentiment of the article. So a credit risk manager is really interested in mainly negative news. So a negative sentiment is more important for a credit risk manager than a positive sentiment. So we'll just analyze the sentiment. And here it says, okay, we have a sentiment score, which is normally between -1, which is very negative, and 1, which is very positive, of 0.26, which is quite positive. And here we have a magnitude. The magnitude is a number that represents the number of expressions of emotions used in this text. It's 3.3. The second thing we do with NLP is we analyze entities. And this is really an important part for us, because we want to extract the entities, and we want to know which entities is this article about. So let's run it. Well, here you see it extracted Ad van Geels as a person, and it also extracted PwC Netherlands as an organization. And here you see why the Wikipedia is so important for us, because we just search for PwC. And when we search for PwC, we don't know if the results are about the PwC we are looking at. But we know that when NLP processed it and says, hey, this is the Wikipedia of this company, and then we know, we have this Wikipedia in our database, now we can make the match, this is really the company we are interested in. And I saw this example, let me go a bit up. Here it says, Water Polo Association, PwC, which is a completely different entity. We have a textual match, but probably if we would pass this through NLP, it would not recognize this entity as being PricewaterhouseCoopers. So that's really important. What you also see here is the salience, and the salience is a very important number, and it represents the importance of an entity within this article. So it's ordered by salience, so it says Ad van Geels is the most important entity, and next to that it's PwC. And here we can make a distinguish between is this article really about this entity, or did we just find it somewhere in the article? We also have a sentiment per entity, where we have the same thing like score and magnitude, so we know if an article is negative, we want to know, okay, is it really negative about that entity? Or maybe about another entity. We have a couple of more entities. We only have the proper type entities in here, so not all entities found. And what you here see is also type event. And this is really important for clustering later. So it recognizes a couple of events. So it was about Ad van Geels being appointed as new CEO, and we have appointment as an event here. The last thing NLP does for us is analyze the category of the article. So Google configured a couple of hundred categories, and they have this NLP functionality where it can predict in which category the article is. So in the case that, for example, PwC would sponsor a sports event, the article would probably be classified as sports, and that's a category we are not interested in. So we only use whitelisted categories like these, business and industrial or company news. And here it says it's 90% sure that this article belongs to the category business and industrial. So now we can continue with processing this article. But because these couple of hundred categories are still quite general and not based or not specified for the field of credit risk, we defined a couple of topics ourselves, and we trained a couple of models that can classify the article for these topics. So we trained more than these, but a couple of models with scikit-learn, and these are really good at, for example, predicting if an article is about fraud or about bankruptcy, topics that are really important for the credit risk manager. So here it says it's 11% sure that it's about fraud, 8% sure about bankruptcy. Now we generated a summary, which is a completely newly generated summary, so we can show this in a dashboard. And after this, we can remove the original body and the translated body because we don't need it anymore. We extracted all the information we need from it. And now here comes the last part, which is the clustering. So what we do with clustering is we create one big matrix where all the columns are entities we found in all articles we found. So there are hundreds of thousands of columns in this matrix, maybe even millions, I don't know. And the rows are individual articles. And here you see as a value the salience of that entity in that specific article. So for this example, we will find a related article, just as an example, and we'll add this to the matrix to show you how we do this clustering. So we found a related item about this appointment, and we added it to the matrix. So what you can see is a couple of entities are added here. So these entities are found in the second article, but not in the first article. And also these entities are not found in the first, are found in the first article, but not in the second article. And we can also see that still Ad van Geels is the most important entity in the first article and the second article. And what we can do now is we calculate the cosine similarity, which is just a mathematical formula which can calculate the distance between two vectors. So this vector and this vector. And with this distance, we can say, okay, these two articles are about the same event. So let's calculate it. And here it says, okay, I'm 82% sure, we have 82% match that these for these two vectors. And we can play with the threshold where we say, okay, if we set the threshold at 80%, then these two articles would be clustered together. If we would set the threshold at 85, they wouldn't be clustered together. So that was it for the demo now. This, I think, cost me like 15 minutes. I think on a worker it will take like 15 seconds, and we do it 100,000 times a day. And what really helped us here was the fact that we use Kubernetes engine and PubSub that we can scale. Now we have 250 counterparties in the tool. It will be increased to maybe 10 times this, and I'm confident that we can scale to that amount of counterparties. Thank you. I think back to Otto.
Thank you, Peter, for this excellent demo. And I think now we all understand why your hobby is Kubernetes. I think we've seen that we used a lot of the components of GCP and also that we did quite some coding ourselves. So now I think it's time to wrap up this session. And I want to give you 3 key takeaways. The first is the right information at the right time. We have seen that an international bank needs information from around the globe at the right moment, but also that that information is growing exponentially. So the key question was how to get the right information at the right time at the credit risk manager. And I think that with this proof of concept, we've shown that you can do that. The second key takeaway is cloud and machine learning. Given what we've seen in the past, 3 to 5 years ago, it would have been inconceivable to make this, but now, with the advent of the cloud and also all kinds of APIs and algorithms for machine learning, like translation, like natural language processing, developing a system like this is quite easy. And finally, agile working and fast experimentation. We have demonstrated that with the right tooling and the right team, you can build a proof of concept from scratch in just 12 weeks. And you can do that as well and start tomorrow. Thank you for your time.